So in the most recent video, I think that's dynamic number 17, uh, we analyzed what will happen if the block is greater at point A, or the mass of block A is greater than the mass of block B. So at this point, we will also analyze the same condition where A is greater than B, but this time it is there is a rough surface. Okay, so this is a rough surface, not smooth. So therefore, we have to consider friction. So we have to consider friction. B is less. Okay. Now the thing is, and then letter B, okay, letter B or letter A. Let's analyze letter A first. Let's justify: will it move or not? Okay, will it be able to move or not? Okay. Second, what is the maximum mass? Okay, so that whatever the state of motion is. So for letter B, we all know that acceleration should be 0 because we have to keep it at the same state of motion. Same state of motion. For letter B, will it move? So it doesn't need to change the state of motion. So it means if it originally at rest. Okay, so let's put this condition. So V naught is 0. So it means the initial velocity is 0. And what do you think will happen with the final velocity? Will it start to move? Okay. So this is for condition letter A. For question letter B, it is stated that the initial velocity, if the initial velocity is 0, the final velocity should also be 0, as it states over here, to keep the same state of motion. So we'll keep it at the same state of motion. Again, we all know that we've been using subscript like m sub A, m sub B. And my suggestion from from the most recent video is that instead of using subscript, we can say that uppercase M, since there's only 2 blocks, should be greater than lowercase m. And based on this statement in question letter A, M will be our mass of A since it's greater, and lowercase m is mass of B, which is less. Okay, less than mass of A. So first step, let us work with our free body diagram. Similar to the most recent video. So free body diagram, where I have my X and Y. This is your Y-axis, this is your X-axis. Y-axis and X-axis. And at the same time, with our block letter B, we also have our X and Y. These are the 2 dots, and then we have to consider 2 free body diagrams in this solution. So we have our 2 forces, 2 blocks. So we have body A, and then we have the second body B. Body A and body B. So if A is greater than B, then let's do the same illustration we have from the previous video, where we have f of g of A. We have 4 sections, while for letter B, I will just use 2 sections, which is fg of B. Let's say that's the ratio. Now, we have the normal force on A, which is the same amount of force because there's no other forces acting along the y-axis. Okay, opposite and equal reaction. So if I have 4 sections, 4 segments, 2 and 4, I have 4 segments also. So I have my 4 segments, F of our normal force along A. Now, the difference now is that you do have the tension force. So in our previous illustration, I was using maybe 1 section right here. So how about if I'll draw, assuming that the force of tension assuming that the force of tension, so force of tension is right there, okay, force of tension is the same as the force of gravity. Okay, so let me make that assumption, condition B, that they're the same. Okay, so there's no state of motion, so it's not gonna move first. Okay, so I have my force of tension right here also, and then at the same time I do have, this time I have an opposing force, which is the force of friction. Okay, force of friction, I don't know if that force of friction is moving or not. Okay, so let's figure out force of friction. Okay, we were given mu of k, mu of s. Okay, mu of k, mu of s. So if we don't want our object to move, then we will use the coefficient of static friction. Okay, so coefficient of static friction, coefficient of static friction. So I will place it here. Okay, so I will place it here. Coefficient, not coefficient of static friction, but I will make the assumption that I am having a static friction based on letter B. Okay, so letter B is right here. So the maximum mass at B to keep the same state of motion. Okay, so what I'm trying to do here is to see where I have a much better condition, and that is condition for question letter B, because most of the information are already provided. So next step is to analyze the different forces acting on each body. So let me just use the red ink over here. So what are the forces acting along the y-axis? So what are the different forces acting along the y-axis for letter A? Y-axis is equivalent to mass times the acceleration along y-axis. But we all know that there's no motion along the y-axis. Okay? For letter A, there's no motion along y-axis because of the board, because of the plane. So I can say that the summation of forces going up is positive, so that's normal force, minus the force of gravity at A is equivalent to mass of A, which is, in this case, that is m multiplied by 0. So that's still going to be 0. So normal force minus FGA, that is equivalent to 0. Or I can say that the normal force is equivalent to the force of gravity, but we all know what force of gravity is, and that is the mass of letter A, which is uppercase M multiplied by G. So this will be our normal force. Second, what is the result if we do force along the x-axis multiplied by is equivalent to mass acceleration along the x-axis? Now, since we are making the assumption using condition B, okay, question letter B, where it's not moving, so let's start using that one. So we all know that acceleration is also 0. Anything going to the right, which is Ft, minus the force of friction, S, static because it's not moving, is equivalent to mass times 0. So we can say that Ft minus F of Fs is equivalent to 0. So we can simply say that the force of tension is simply equivalent to the force of friction that is applied. Okay. So they're equal. So if they're not moving, so that's static friction. And then we can just simply say that this is equivalent to mu of k, mu of s, static friction, coefficient of static friction, multiplied by the normal force. But we all know that the normal force is m and g. So we can further say that the force of tension is simply equivalent to mu of s multiplied by mg. So now I have my force of tension. Let's analyze letter B. There are now forces acting along the x-axis, so we don't have to worry about it. So the only force acting about it is your y-axis multiplied by the acceleration along y. Now, since we are assuming working on letter B first, So we can say that the force is acting positive, that is going up, minus F of GB is equivalent to mass, lowercase m, multiplied by 0. So now we can say that our tension minus, what is our force of gravity? Or, yes, force of gravity in our case, that's mass, lowercase m, multiplied by g is equivalent to 0. So we can further say that Ft is simply mass times g. Now we can equate F and T together. So F and T together. Now we can put those two together. So we have mu s m of g is also equivalent to m and g. So we are equating both Ft, or the force of tension right here, to come up with this equation. So now, what is the maximum mass? So we can cancel our g, because that's g on both sides if we divide it. So we can say that the maximum mass must not exceed whatever the static of coefficient of friction is. Okay, so the static of coefficient of friction, coefficient of static friction multiplied by m. So lowercase. Okay, so if your mass, if you multiply mu s by the mass of A, and it is here, okay, within m, that's the mass of your B, then it will not move. Okay, so it will not move if it started at rest. Okay, so it will not move if you start at rest. The only time it's going to increase if you change the value of this coefficient of static friction, and that it will be less than this part. Okay, so the smaller the number, you multiply it by m, what will happen? The lesser the coefficient of static friction, or the coefficient of friction, what will happen? Mass of letter B, or the force of tension, the force of friction on this side, on letter A, will not be strong enough to hold it in place. So it will start to slide. Okay, so letter B, we already know the answer. How about for letter A? Okay, so letter A. So let's come up with an explanation for letter A. Now at this point, we weren't able to prove anything. We weren't able to prove anything. Okay? We weren't able to prove anything. Will it move or not move? Okay. The only time you will be able to prove that it will move if and only if, for letter A, we will consider, okay, so we will consider that the mass is greater, or m is great. The mass, okay, so let me just hold my breath over there. So the mass that we attached on letter B, or mass of B, is greater than the product of the coefficient of static friction and the mass of block A. So it all depends. So we were able to come up with an answer for letter B. Okay. Now, what is our possible answer? What is our possible answer for letter A? Okay. So we can just say here that letter A, so let me put for letter A, what is our claim? So we can say that the claim okay, the blocks will move if and only if, okay, the mass of block B is greater than the product of mass A and the coefficient of static friction, mu s. So that will be our claim. the blocks will move if and only if the mass of B is greater than the product of mass A and the coefficient of static friction. So we can further say, as shown in the calculation, okay, so what will be our evidence and reasoning? Use a different color. So what will be evidence and reason? Evidence and reason, we can now say, okay, as shown in the calculation, okay, as shown in the calculation, there's no change in the state of motion if M is equivalent to the product of mu s and M. So these are the conditions that we must indicate. Okay, so these are the conditions we must indicate. Will it move? Well, we don't know. We don't have values. Okay, so if they provide you with the values, you can. However, you have established the condition, when will it move or when will it not move. So M should be at least, okay, so it should be at least equal or less than mu s times M in order for it to move. In order for it to not move, to establish. Okay, so let's see what the next video will give us. Maybe another scenario. If you're watching this actively, please send some comments or give me some suggestion on what other problems that you might want to have a solution about.